Welcome back to your favorite intermediate algebra class. We're going to graph some quadratic functions and use them to solve some real-life problems. So let's talk about a quadratic function. A quadratic function is any function of the form y equals ax squared plus bx plus c. Okay, that's your standard form, and a cannot be 0. Okay, so the most basic parent quadratic function, if you will, is y equals x squared. So if you were to take a look at this and plot some points for y equals x squared. Let's say you plugged in like 0, 1, and 2, 3, -1, -2, -3 for x, right? We plug them in one by one. So we plug in 0, we square it. Y must be 0. Plug in 1 now for x. 1 squared, of course, is 1. Plug in 2 now. 2 squared is 4. Anyways, we keep doing this. 3 squared is 9. -1 squared, -1 times -1 is positive 1. -2 squared, of course, is 4. -3 times -3 is 9. So we get these points. We take a look at this thing. 0, 0, 1, 1, 2, 4, 3, 9, -1, 1, -2, 4, -3, up here at 9, and then we start drawing this, and you could plot some more points if you wanted to kind of get the feel for this. This is called a parabola, this U shape, okay? So quadratics have this U shape, either they open up, okay, or maybe they'll open down, but it all depends on the A value, okay? So if your A value, the number in front of the x squared, and in this case the number in front of the x squared is 1. If that A value is positive, it'll open up, just like you see right here. So there's a parabola. Now, if the parabola opens up, you're going to have this lowest point. That right there, that's called your vertex. That's your vertex, okay? And on your vertex is what's called the axis of symmetry. Okay, so this axis of symmetry is the line. Okay, this axis of symmetry is the line about which you notice that it's reflective. For example, you have the 2.24. So if you go over 2, you're up 4. Well, if you go the same distance to the left of this axis of symmetry, you know, right here you're 2, 4. If you go the same distance to the left, you'll be at -2, but the same y value 4. Okay, so it's reflective about the line. If you take this point, go to the other side of the axis of symmetry, the same distance, you see it right there. Okay, so the axis of symmetry is that line, that vertical line right down the vertex there. Okay, so let's talk about graphing some more. And this parent function, every parabola is some manipulation of this basic y equals x squared. Okay. All right, so it's a parabola. We have these characteristics. Okay, it opens up if it's positive, opens down if it's negative, and then we'll talk about if it stretches it or shrinks it, okay? So if the absolute value of A is less than 1, it's going to be narrower. Okay, oftentimes they call this, if it's narrower, sometimes they'll call that a vertical shrink in your textbook. Okay, now, I'm sorry, vertical stretch, that's your skinnier, sorry about that. Textbook's now wider. If it's wider, that's your vertical shrink. Okay, so for instance, you know how the old parent function was y equals x squared? Well, if it's a lot wider, like that, okay, for example, y equals 1/3 x squared, okay, that's called a vertical shrink. Okay, vertical shrink. On the other hand, if we would have had like y equals 2x squared, that's called a vertical stretch, okay, because it's narrower if you were to graph that. Okay, so that's what that portion's talking about. Depends on your A, okay? Then you notice there the x-coordinate of your vertex and the axis of symmetry. All right, let's go through this. We'll take those steps one by one. We'll talk about each of those characteristics, okay? So y equals -x squared plus 2x minus 2. So I'm thinking to myself, well, here's my equation. It's in standard form. Let me make sure it's in standard form. Okay, it is. And now number one, I'm going to think about, does this thing open up or down? And I say, well, since A is, so you notice A is negative 1. Since A is negative 1, i.e. is that positive or negative? A is negative, right? This thing's going to open down. It'll cause this thing to open down. So I'm thinking to myself, I don't know where it's at, but it's going to be something like that. Okay, it's going to open down. Now, second thing I'm going to think about is where's my vertex at? Okay, well my vertex is on my axis of symmetry. And my axis of symmetry can be found by this equation, x equals negative b over 2a. Okay, so x equals negative. Now we go and identify our b. What's our b value? And I say, well, b right there, you see how our b must be positive 2 over, we got 2 times our, what's our a value in here? What's our a value? And I go back up here and I say, well, a must be that negative 1 out front. Okay, so the axis of symmetry is x equals negative 2 over negative 2. X equals 1 in this case. So I go to my graph, and I'm going to put the vertical line x equals 1 on my graph. Okay, so my vertex is somewhere on this, and this parabola is reflective about that line. Okay, now number 3 is I say, oh, okay, well that means once I start plotting this, I know my vertex is at that x value. Now I got to figure out the y value for it. And then once I have the vertex, I'm going to pick a couple points to the right of that. So to the right of the vertex. And then I'm going to pick a couple points to the left of an x value of 1. I say, well, to the left of the x value of 1 would be 0 is your next one to the left of 1, and then negative 1. Okay. So let's find the vertex first. Let's plug in 1 here. So I go back to my equation. Y equals negative x squared plus 2x minus 2. And let's plug in an x value of 1. One squared is 1. 2 minus 2, of course, is gone. So it looks like y equals negative 1. Okay, so negative 1. So our vertex is at this point 1 comma negative 1. Now you remember this thing opened down, right? So that's going to be my highest point right there. 1, negative 1. Okay. Now I'm going to plug in 2. Okay, so I'm plugging in a couple points to the right, couple points to the left, and so on. Okay, so y equals negative. Plugging in 2. Negative 4 plus 4 is gone, so I'm just left with that negative 2. So I got negative 2. Now I plug in negative 3. I'm sorry, positive 3. Okay, negative 5. Okay, so 2, negative 2, 3, negative 5, 2, negative 2, 3, negative 5. Okay, you can kind of see that to the right of this thing, see how it's dropping down there? Okay, since this is symmetrical, you notice that if I'm a distance of 1 to the right of the axis of symmetry, I should be that same y value over here. So I should get that right there when I plug in 0. And then when I plug in negative 1, I should get that point right there, right? Because this thing is symmetrical, okay? Symmetrical. So let's plug in 0. Make sure we get negative 2. So we go through it. Negative x squared plus 2x minus 2. You plug in the 0. That's gone right there. That's gone right there. So those are gone, and you got the minus 2 on the end. So 0, negative 2. Then you plug in the negative 1. Negative 1 squared is 1. 2 times negative 1 minus 2. So negative 1 minus 2 minus 2, negative 5. So y is negative 5, and there you go. Yeah, you notice that those have the same y values, don't they? And then these ones have the same y values, don't they? Okay, and again, because this is symmetrical. Okay, so that's what that looks like. That's how you're going to approach it when you're graphing these in standard form. Let's do one more here. All right, you notice your A is a half, your B right up above the B is -1, and your C is -1, right? We're going to start out, does this thing open up or down? And we say, well, since A is a half, so A is positive, this thing's going to open up. Okay, so it's going to be something like that, right? Opens up somewhere. Number 2, got to find this axis of symmetry. That's our starting point. Axis of symmetry is found x equals -b over 2a. That's the equation for the axis of symmetry. So negative, our b value is -1 over 2 times, and our a value there is a half, right? Right there. So we got +1 over 2 times a half. Well, you got 2 over 2, right? So 1. So we got another x equals 1 here in this case. X is 1. There's our axis of symmetry, and we know this thing's going to open up, right? Okay. Number 3, so I now say, you know what? On my axis of symmetry, I have my vertex. So at 1, pick a couple to the right, pick a couple to the left of 1, and I'll be good to go. Go back to my equation. ½ x squared minus x minus 1. We're plugging in 1. So half times 1's a half. -1 minus 1 minus 2. So it looks like that's a half minus 4 over 2, or -3 halves. Or -1½ right? -1½ So at 1, I'm down 1½ 1½ So I'm right there. There's my vertex. Except this one's going to open up. Okay, so we plug in 2. We plug in 3. Okay, one by one. So let's plug in 2. So y is -1, 2 comma -1, 2 comma -1. So you see how that's a little bit above that, right? If we were to plug in 0, we're also going to get -1, right? That would be gone, and that would be gone with our zeros there. So we got the -1 on the end. We know this thing is reflective about the line. Now let's plug in 3. Plug in 3. 1/2 3 squared minus the x minus 1. Half of 9 minus 3 minus 1. 9 halves minus 4. I'm going to write that as 8 halves. So we got a half. Okay. 1/2. We plug in -1. We get a half. Right? So 3 comma. I'm up halfway. And we plugged in -1, and we got a half here. Okay. All right. Notice on this one our A value here. Our A value was a half, right? A was a half. Now, if that absolute value of that number, if it's less than 1, you know how you got a half, the absolute value of a half, of course, is less than 1, then it's going to be what's called, this is a vertical shrink. So it's a little wider. It's a little wider. So instead of like the typical standard, if your A value was 1, do you see how the red one's a little wider? That's a vertical shrink, and again, that's because your absolute value of A is less than 1. Had the absolute value of A been greater than 1, so like instead of a half, let's say it was 3, then you're going to see something like this. Okay, a vertical stretch there, that's called. So it'd be a lot skinnier, if you will. Okay,